For problem 2, we're told that this car accelerates from 0 to 60 in just 10 seconds. And we have the 0 to 60 is in miles per hour, and of course our units for time are in seconds. So we already have a units mismatch. So suppose that the car's velocity is given. We want to estimate how far the car travels during a 10-second time period. And what you need to do is deal with the units, and I would probably do that first. In your key, it says it gives you the answers in either feet or miles. I think I'm going to switch to feet. I know that miles per hour are going to be 5,280 feet for 1 mile. So I can cancel my miles and I will have feet per hour, but also I need to put it in terms of seconds, so I know that 1 hour will be 3,600 seconds. So then I can cancel my hours. So basically I know that I have, my units are going to be 5,280 feet per 3,600 seconds. 1 block will be 1 second times 10 miles per hour. So I needed, originally I needed to have in here 10 miles per hour, and then of course the 1 second makes sense. So this is going to be multiplied by 10, which means I have 5,280 over 360 feet per second is the area of each block. So when I pull out my calculator, I estimate that to be 14.67 feet per second times 1 second, which means that each block is actually 14.67 feet, because I was trying to find the area of each block. So the vertical distance of each block is the 14.67 feet per second. The horizontal distance is 1 second, so each block is 14.67 feet. And now the question is, how many blocks do we have? So this one is just a rudimentary exercise in counting blocks. Every time I put a single dot down, that means I have a full block. So let's count up how many full blocks there are, and then we can figure out how many partial blocks. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 18, 21, 23, 24 full blocks, and then I'm going to start adding partial blocks. I'll say 0.4 plus 0.9 is 1.3, plus 0.7 is 2, plus 0.5 is 2.5, plus 0.5 is 3, plus 0.4 is 3.4, plus 0.9 is 4.3, plus 0.2 is 4.5, plus 0.7 is 5.2, plus 0.9 is 6.1. So I'm saying 30.1 blocks times 14.67 total blocks, or feet per block, and I'm getting, when I do that out, I'm getting 441.667 total feet. And I know your answer key said 440 feet, but this is an estimate, and that worked out to be close enough if you ask me. Next problem, number 3, says estimate the integral from 0 to 20. This is another exercise in counting blocks. This time I don't have any units mismatch at all, so I really just need to figure out that each block looks to be like, if I, let's see, this is, each of these is 4 and that is 1. So 1 block will be worth 4. So the question is, how many blocks do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 full blocks, plus partial blocks, maybe 0.9, plus 0.4 is 1.3, plus 0.9 is 2.2, plus 0.5 is 2.7, plus 0.9 is 3.6, plus 0.3 is 3.9, plus 0.7 is 4.6, plus 0.3 is 4.9. So I'm getting 14.9 blocks, and each block is 4. And I'm doing good old multiplication by hand, and I'm getting not an answer that made sense when I should have not done multiplication by hand. Bad idea. So now I'll do my multiplication in my calculator, and I'm going to get 59.6, which is pretty darn close to what the answer key said, which was 61.2. And again, since these are estimates, that's about all we can do. And then the last problem I'll do in this video says my velocity is given by the velocity function sine of t squared on the interval from 0 to 1.1. And we want to know the distance traveled using the integral on our calculator. So I'm going to pull up my calculator and we'll get to this problem. Okay, so what I'm going to do is go to my graphing screen, and there is a reason I want to be on the graphing screen, because I want to check to see if my graph ever crosses the x-axis on the interval from 0 to 1.1. So I'm going to plug in sine of x squared, and I know that they gave us t squared, but on the graphing screen I need an independent variable of x. And the window I'm going to change to be my x value from 0 to 1, x will be from 0 to 2, and then my y value, I think I'm okay. This goes from negative pi over 2 to pi over 2. That's fine with me. So here is my function starting at x equals 0, and there is a point at which the graph crosses the x-axis, but now I'm wondering if that is beyond my domain of 1.1. So I'm going to just go ahead and evaluate the function at 1.1. And I see that on the interval from 0 to 1.1, the sine of t squared function does not cross the x-axis, and therefore my integral will be exactly equal to the total distance traveled. Since I'm on my graph screen, I'll go ahead and integrate right here. I go down to choice 7 and hit enter. My lower limit will be 0, and my upper limit will be 1.1. And my answer is, shading right there, busy calculator, but 0.399. So the integral sine of t squared from 0 to 1.1, that's dt, equals 0.399.